Hey guys, so this right here is a short video just to prep you on what you should be looking for when you see this on your assessment, okay? So make sure that you watch this video as closely as possible and as many times as you need to, okay? So make sure that you write down these notes. This will be notes number 17. So here we go. We want to discuss all characteristics of this polynomial function, and using that information, we want to develop an equation that will represent this function on the graph shown. So over here. So I took a screenshot. So I typed in a function and out came this graph. So you have to use what you guys have learned throughout this whole unit to develop what you think the equation will look like. So we're working a little bit backwards, okay? So here we go. I noticed, okay, that the graph starts at the bottom left and that the graph ends at the upper right, okay? Let me say that again. The graph starts at the bottom left and it ends at the upper right. So I know that the limit of this function as x goes far left, it goes far down. And I know that the limit of f of x as x approaches the far right, it goes far up. So that tells me the end behavior, okay? And this looks like it behaves like a positive line. Okay, now it doesn't behave like it in between, but at the end, they start at the bottom left and they end at the upper right. So that tells me that the degree must be odd and that the leading coefficient must be positive. Okay? Now, if the graph was going the other way, I would probably say that the degree is odd and the leading coefficient is negative because it's going in the opposite direction, okay? Now, I know the degree is not even because they start and end in different places, okay? The two limits are different, so I know the degree has to be odd. Now, if the two limits were the same, the degrees have to be even. Okay? And this is where you guys would definitely want to review older videos here, okay? So we know that that's going to be true, okay? Okay, I also noticed that the y-intercept, which is pretty much where the graph crosses the y-axis, intercepts right at negative 12 when x is 0. Okay? I also know that the x-intercepts, or the roots, looks like it crosses 3 different areas, once, twice, 3 times, okay? Now I notice that the roots are x equals negative 1, x equals positive 2, and x equals positive 3. But I did notice that at negative 1 and at positive 2, they did not cross. Okay? Notice how the graph kind of just touches it and then turns right back around. But at 3, it cuts right through. It crosses. So I go back to my notes. What are the implications of it, right? So I know that if it crosses, that means the multiplicity here is odd. And if it doesn't cross, I know the multiplicities here are even. Okay. Okay. I also noticed that there are, let me erase this so you guys can see. I noticed that the function starts to increase then it decreases, then it increases, then it shortly decreases, and then it increases again. Okay, so I'm describing the change in intervals here. I'm not going to mention where the intervals are because it's kind of tough to do, but basically it starts to increase, then it decreases, then it increases, then it decreases, then it increases. Okay, so I'm describing the change in intervals. Okay. What else? I noticed that there are 4 local extremas. Specifically, here there are 2 local maxes because locally those are the highest points, right? And I have 2 local minimums right there, okay? Now, I don't know exactly where they are, all of them, so I'll just say that we have 2 local maxes and 2 local mins here in this picture. Your picture may be different, all right? I noticed that the graph goes all the way up and all the way down, so that means that this is unbounded. So you guys want to be able to include all of these characteristics here, okay? Now, since it's a polynomial function, I know that the domain is always all real numbers. So negative infinity to infinity here, okay? Now, the range here goes all the way up and all the way down. So I know the range will go all the way down and all the way up as well. Okay? For all polynomial functions, the domain is always all real numbers because polynomial functions will never have square roots or fractions. All right? Okay, what else am I missing here? Okay, that's enough to discuss all the characteristics, okay? Now, using this information that we have here, how do we develop an equation? So I want to start it off by saying f of x equals, and make sure you guys say f of x. Don't say f times x or f parentheses x. It's f of x, okay? Now, if, I'll use purple here. If I know that x equals negative 1 is a 0, then I know my factor has to be x plus 1. Think about that. Okay? Now I know that x equals positive 2 is a 0, so that means the factor must be x minus 2. It's the opposite. And since x equals 3 is a 0, then x minus 3 has to be a factor. You call these factors here, and you call these zeros here. Remember, when you guys make your videos, I pay close attention to how well you articulate your thoughts. So make sure that you guys are using the same language, okay? Okay, so here we go. But I also notice that there are multiplicities here. Okay, so I know that with the 3, the multiplicity has to be odd, so meaning the exponent right there has to be an odd number. We have to have an even number here, and we have to have an even number here. Okay, so this is probably the most challenging part. Okay, so I know that I have to get a y-intercept of negative 12, meaning when x is 0, okay, when x is 0, this becomes 1. When x is 0, this becomes negative 2. And when x is 0, this becomes negative 3. Okay? I don't quite know what goes up here yet. Okay? But I do know that this has to come out to negative 12. Okay? So, I know that the multiplicity for x minus 3 has to come out odd. Okay? So I'm just going to go ahead and guess that this should be a 1. Okay. Now, I know that the multiplicity for x plus 1 has to be even, so I'm going to try out 2. Okay. And I know that the multiplicity for x minus 2 has to be even as well, so I'm going to try to put a 2 here. Okay. So let's see what happens. 1 squared is a positive 1. Negative 2 squared is negative 2 times negative 2, which is positive 4. And negative 3 to the first power is just negative 3. If I multiply that out, I actually get negative 12. So I know that this is good. So what I'm going to do is I'm going to insert the exponents right there. So this right here is my function. Okay. Now, let's go back because I want you guys to think about all the scenarios here. So again, this is the toughest part, coming up with the exponents. Now, knowing that x minus 3 has an odd multiplicity, okay? I could use numbers like 1 or 3, but I know the moment I put a 3 here, it wouldn't make any sense because then negative 3 to the third power is negative 27. It's getting too large in the sense of negative values, okay? And I only want a negative 12. So you guys have to take your time here and kind of play with it until you get the value that you guys want. So this is your one example. Watch it 10, 20 times if you need to. And then you come up with your own video, okay? Again, I look for articulation, how well you explain things, and how detailed you are, okay? And again, you guys can re-record as many times as you need to, but everyone is going to get their own unique problems. So make sure that you're just as detailed. You can watch this video as many times as you need to until you feel like, okay, I get it, Mr. Lee. All right? Good luck.